friends, give the warmest of EIC Summit welcomes to our final kickoff speaker of the morning, Mariana Popescu, Assistant Professor of Digital Fabrication at TU Delft. Good morning.
Morning. Nice to be here.
Here you go.
Thank you very much. Good morning. I come to you from the architecture, engineering, and construction sector. And unless you're part of it or very closely related to it, it's probably not one of the first sectors that comes to mind when talking about climate change. And yet, it is responsible for over 30% of all the process-related greenhouse gas emissions. That also means that it's one of the sectors that we can have incredible impact with. But that does require us to fundamentally change how we think about designing and building our structures, so that they are more efficient both in their performance and their overall material use. The good news? We can design structures that intelligently include material efficiency and structural performance in architectural geometry. The result are these beautiful, elegant structures that effortlessly span space using very little material. The downside of these types of structures, though, is that they have, well, intricate, complex, non-repetitive geometries that we're not usually used to building with our traditional techniques. And those techniques heavily rely on timber formworks or milled formworks that are heavy, they're clunky, they take a long time to produce, but very importantly, in the case of these types of special structures, they're only used once. So it means they turn into a massive pile of waste afterwards. If we don't want to just simply switch our problem from the structure itself to the way it's being constructed, we really need to radically rethink or come up with these types of solutions that enable us to build these structures. And one solution, the one that we currently work on, focuses on using textiles instead of traditional formworks. They're a lot lighter than wood, they're fast to produce, they're easy to carry around, and ultimately produce a lot less waste than traditional formwork would. Now, we specifically focus on knitted textiles, and the reason for that is because you can tailor knitted textiles. You can have them made, prefabricated, with direct 3D shapes. And they can not only have 3D shapes, but they can have very specific local material properties that we can design and control in the fabrication process. You're probably very familiar with all of this from everything that you're wearing or your shoes, your performance shoes. Now, the way this works as a system is we start with a design, hopefully a structurally informed design, or at the very least, a fabrication-informed design. We produce a fitting textile on existing industrial knitting machines. We take that textile to site very compactly, almost in our backpacks. We stretch it or tension it into shape using temporary rigs, or in this case, some cable nets. And we coat it with a thin coating that gives it initial rigidity. The result is an incredibly lightweight formwork that can be used directly to cast into. Now, one of the tricky parts here is not only how we build with it, but coming up with the computational pipelines that allow us to translate a designed geometry into instructions for a knitting machine, and doing so for geometries that are not the size of our clothing, which is what they usually build, but the size of our buildings. Now, what I showed you here is a tiny node, but behind me you'll see a bigger structure, that clicker worked, that we've built with exactly this type of technique. So we built the 50 square meters of formwork with the textile that you see on the inside of this structure. We took it to site in our carry-on luggage. We tensioned it into shape with a cable net and applied concrete onto the one side of it and resulted in this structure. Now, the takeaways from using a system like this are that the 50 square meters of formwork that were required cost about 2,500 euros. The textile itself weighed 25 kilos. The cable net that held it up, another 30. So it's safe to say that about 55 kilos carried 5 tons of concrete. And it took a mere 36 hours to produce a textile that would for a formwork that would otherwise take about 750 hours to mill. That's 20 times more. We built the entire structure, or delivered it from the design to the structure standing there, in 14 weeks. And if we were to use traditional methods, it would have taken just that time to produce the molds. So the implications are quite significant. Now, with our methods, we can, at the moment, design efficient, flexible formworks. We do have the pipelines that allow us to also tailor and make very specific material, graded material properties, and the pipelines to fabricate them. And now with our EIC Pathfinder project, we're trying to close the fabrication-aware design loop so that we can include both the fabrication constraints and the resulting material properties, mechanical material properties that are quite complex for these, within the design process. So once we have that, quite a lot of the pieces are in place. Most importantly, the infrastructure is kind of there. We're using traditional existing industrial knitting machines, and they're already all over the world producing our clothes. All we need to do is send them the instructions for our buildings instead. So at the end of the day, when all of the pieces fall into place, what's still missing? Well, for the AEC sector to adopt these types of technologies and the other ones that are being developed within our portfolio. Thank you very much.
Mariana Popescu. I can take that from you. Thank you.
Can
I keep that? Can I keep it?
I'm very attached to it, but you can keep it for now.
For now. Awesome. All right, I'm selling this. Anyone? Highest bidder.